Okay, so I'll start with the visualizer. So it's best to start off in one of the test command pairs. So you can visualize a collision volume by passing in a collidable with the color to the visualizer to show collision. And then this will call debug view on the collision volume. Debug view is a virtual method which is explicitly defined by each of the individual collision volumes. So I'll go into bSphere. So then each volume defines what should happen when debug view is called. So for bSphere, it does show, it calls show bSphere on the visualizer, ABB, show ABB on the visualizer. Okay. And then it'll grab all the necessary data for calculating that volume. And then it will create a command and put that inside of the draw broker. Well, actually, I believe the way I have it set up is, yeah. Okay, so the draw broker, it stores the commands. So yeah, if one doesn't exist, then if one does exist inside of the pool, it pulls that one and then sets that command according to the information passed in, or creates a new one and then sets it up. Yeah. And then going back to visualizer. So it creates the command, and then actually I should look at the command. Okay. So it stores the world, its color, and the volume, a pointer to the volume. And then when execute is called on the command, it'll call render view on that volume. This is another virtual method on the collision volumes that is explicitly defined on each volume. And then it'll call its appropriate render call. And then this render call actually renders the object onto the screen. So yeah. So I have a system for rendering a ABB, an OBB, a bSphere, and a point. And for the point, you only need to pass in the position and the color of the point. I only have two graphic objects, one for the box volumes and one for the spheres. And then just like a small thing I added in last minute was a toggle command. So toggle visualizer. So where is it? Here. Okay. So inside of the scene, where's the scene? In the draw stage, it draws all the object and then it makes a call to process the visuals. So depending on yeah, it'll call execute on the specific toggle command. So let me open those up. Yeah, okay. So if the visualizer is toggled on, it will execute the commands, and then that will actually draw the wireframe objects. However, if the visualizer is toggled off, the execute will be called on the toggle off command, which it'll still iterate through the list of commands, but it just won't execute them, so they won't show on screen. So yeah, so this way, like in my demo, I have the toggle mapped to the V key. So if you press V, it'll toggle the collision, the visualizer on and off, so you can see collisions and all the other stuff that the visualizer processes. So yeah, that's it for the collision for the visualizer. As for the math tools, so okay, so I have my 6 pairwise intersections between all the different volumes, and then I have a plethora of helper methods, which are utilized by the intersect methods, but they can also be utilized by the player or elsewhere. Like if the player needs to clamp a vector point or anything like that, or get the min and max of 2 points, stuff like that. Yes, I believe all of these methods are used for OBB versus OBB or ABB collisions. Yes, get face normal from points. Was this? Yeah. Okay, so here are the actual methods. The intersections, the clampings, min and max. Min and I believe I use this inside of my terrain when calculating the cells min and max. So I pass in the 4 vectors that make up the cell in the terrain, and then I do min and max on those, and then I get the min and max out of those 4 points. And then get 15 axes. This is used for OBB and OBB stuff. Yeah. Okay. Get face normals. And get face no. Okay. So these are used to this is used also in my terrain test. What it does is well, given 3 points, get the normal of that face. So yeah. So I use that to get the normals around I call this 6 times to get the normals surrounding a point on my terrain, and then I average those out, and that gets me the normal of that vector at that vertex at that point. And yeah, I believe that's all I have for the visualizer and math tools.